Hello everyone, and thank you for joining me again. In this video, we're going to be looking at question number 18 on our 2012 Cayley Math Contest. 6 consecutive integers are written on a blackboard. When one of them is erased, the sum of the remaining 5 integers is 2012. What is the sum of the digits of the integer that was erased? Okay, this number should likely be uniquely determined in order to get the sum of the digits. Now, I don't quite know what the numbers are. Now, we might say, oh, six consecutive numbers, maybe call them n plus 1, n plus 2, n plus 3, n plus 4, and n plus 5, and try and set up an equation this way. Except I don't know which one was erased. Is it this one? Is it this one? I have no idea. Okay? And so we could try to find out which one was erased this way. But I think it's going to be a little bit of trouble. Okay? Now you could randomly say, oh, maybe this one was erased, and then add up the remaining ones, set that equal to 2012. So that'll be 5n plus 13, and see if that works out. And you can see no, because subtract 13, you get 1999, which is not a multiple of 5. So, okay, well, now I've got to try again. We could do that, could guess and check our way to success, but we want to try and be a bit more precise. And to do that, we're instead going to be a little imprecise. The 5 numbers that we add up, they come from 6 consecutive numbers, so we can agree they're all pretty close in value. Okay? So they're all about, they're about number k. So 5 of them, if you added up them all, you'd get roughly 5k as your sum. Not quite, but roughly 5k. And if I divide 2012 by 5 and I'm expecting an integer, well, you round down, you can get 502, or you could round up to 503. It doesn't really matter. What I'm now going to do is I'm going to say, okay, the numbers that we added up are roughly 502. So these 6 original integers should roughly be around 502. So we could write some of them out. So 502 is sort of the average of these numbers. So let's put it in the middle. So those 5 numbers don't add up. They add up to 2010 when you work them out. Well, that's close to 2012. I just need 2 more. So what if we did something like took away the 503 and replaced it with 2 more than that, 505? If you add those up, you do get 212. So we just had to play around with that. Okay? Now the reason I targeted the 503, I could have added 2 to any of these. But if I got rid of the 500 and added 2 to it, then I've got 2 502s. So I needed to look for something on the end like 503 or 504. Okay? So we could have, so if we had tried to get rid of 504 and add 2 to that, it's 506, and you wouldn't have started with 6 consecutive numbers originally. So that's why it's got to be 503 that was erased originally. Okay? So our numbers were 500 through 505, and as already stated, we erased 503, and the sum of the digits there is 8. So 8 is nowhere to be found. Oh, here's my problem. I tried to calculate this in my head. It's 402. 402 when you divide by 5. That's my mistake. I'm sure somebody's been screaming at their screen about this. There we go. Oh, that would have been disastrous if 8 had actually been an answer. But it looks like it's 7. So that's my little goof, but we managed to catch it at the end. And even if you make goofs like that, as long as you leave time at the end of the paper to go back and double check your work really quickly, you can sometimes catch these sorts of mistakes. I managed to catch it just because my answer didn't line up with one of the 5 presented answers. That's a nice advantage of a multiple choice contest. Okay? But I think that's it for question 18. Up next, of course, question number 19.